It's Danielle and Rob here from the BCO podcast, and we are back with episode 4. And this week, we are going to be focusing on asteroids and meteorites and impacts and what's going on in space. And is it a threat or what? But we're going to start off with a little bit of news like we always do. And of course, hello, Rob. How are you? How are things? How was the week since I've spoken to you last?
Terrible. I've been panicking nonstop since we heard about that NASA exercise. They're like, we're not ready. So, yeah, this is why we're talking about asteroids. I haven't been able to move on from it.
Are you losing sleep at night?
Oh, so much. I mean, I was never a great sleeper to begin with, but now I have a real excuse.
Space will do that to you sometimes. It's a little terrifying when you really look at it. It's not the best place for us to be living in. It's not the most welcoming and warm for human beings. Speaking of which, our own planet is just going crazy this week. Did you see the news about the hurricane?
I did. I mean, like, this whole kind of parallel between the threat of like an impact from outer space and the scale of like what that might look like, and dealing with stuff here on our planet with like climate change as well. There's a lot of parallels. Like, it's funny, we were talking during the week and I was joking about that movie Don't Look Up, the one with Leonardo DiCaprio in it, and you were like, oh, it was about climate change. Like, but like the parallels are so close that some people just completely miss that like it is just a parable for how we're approaching the climate change problem.
This is how you know you're too locked into space and the space world, because having that conversation back at work and just going, it was right after New Year's because I watched it around New Year's Eve, and I had come back to Ireland and we were talking about it in labs, and I was like, yeah, it was a really interesting take on space and space scientists and what it's like working in that field and what it's like as a woman working in that field and all of this stuff. And it was a real wake up call when one of our colleagues said, what are you talking about? Like, and it wasn't just to me, it was to everybody in the room. It's like, you missed the whole concept of the movie. It had nothing to do, it obviously had something to do with space, but it was more about climate change than anything else. But yeah, I sometimes am just in a little space bubble where everything just relates back to space. And that's actually when I was looking at the news um this week, because my social media has been bombarded with all the news about the hurricane. And of course I was thinking about how space related to it because it's satellites tracking
Hmm.
Hurricane Beryl, and it's NOAA satellites, and it's the GOES network of satellites. Have you heard of them before?
I haven't actually.
They're a NASA and NOAA collaboration, and they track things like hurricanes. So they're the ones that are GOES are tracking Hurricane Beryl, and the reason this is all over the place and why this is such big news, because it's not really news to have hurricanes in the summertime. That happens every year. This is a regular phenomenon that happens. Why this is such a big deal is because this is the first time ever recorded that we've had a Cat 4, so a Category 4 hurricane recorded in the month of June. So that's unprecedented. And then now it's reached Category 5. So now this is the earliest Category 5 hurricane we've had recorded on record. So this is a really, really big deal. Because we've already seen over the last few years that hurricanes are becoming more frequent and more powerful. And so now we're seeing the hurricane season extended, because I was living in Florida for about 2 years. So I didn't have to, where I was living, we weren't ever hit with a full blown hurricane. We had a really terrible tropical storm that hit and did a ton of damage. Like, couldn't get home, streets were flooded, cars were flooded out, you couldn't drive anywhere. And that was just a tropical storm. So I can't imagine a full-blown hurricane, and then let alone a Category 5, what that's like, because even the winds that for just the tropical storm were unbelievable, similar to the stuff that we get here in Ireland. So I can't imagine being in the path of that hurricane, and these islands that are getting bombarded, they're just getting hit uh, with full force of these hurricanes. That you see the size of this thing is like, it looks like the size of the Caribbean basically, and these islands are tiny. These poor things are getting smashed to bits.
I was just going to ask because we're not as familiar with the category system here in Ireland. Like, we have increasingly violent storms, it seems, in recent years, but we still aren't like talking about category 1 through X hurricanes. Like, how high or low does the scale go? Is a Cat 5 much worse than a Cat 4? How much higher can it go?
Yeah, so category 5, as far as I know, I'm not, I didn't grow up, I grew up dealing with blizzards, so I know a lot more about that than I do about hurricanes. But as far as I know, category 5 is actually, I don't know if there's a category 6. I think category 5 is the highest. Now, they could be increasing the scale based on the fact that we're having more frequent hurricanes and stronger hurricanes. It's really the strength actually that determines the categories. And it is determined by what the wind speeds are. So if it's over 100 miles an hour, it's one, or if it's 100 over, I actually don't know exactly what the category breakdown is. But they're not storm systems. They're not winds that you want to go fly a kite in, basically. Like it's a leveling houses kind of thing. Getting rid of like trees uprooted, not even uprooted, but uprooted and taken off an island to another island, kind of a thing. They're just insane. So they've been tracking this, and it's been very interesting to see the play of space in being able to issue these warnings well in advance, because even though the hurricanes are increasing in power and frequency, we're at least now equipped to have equipment to be able to see them coming from space. Because before, if you're unfamiliar with how the hurricanes move, they come from the coast of Africa across the Atlantic, and then they typically hit somewhere around um, northern South America, the Caribbean, and the southern U.S. Gulf of Mexico area. Um, and so these things are gaining power over the water as they move across the oceans, and then the destruction happens when they come in contact with land. And when they're coming across the Atlantic, as they come into the Caribbean waters, the waters there are much warmer, and so they're picking up energy as they go. So until they hit land, they're just strengthening and strengthening and strengthening. So it's fantastic that now we have satellites that are monitoring huge distances, because these huge storms could be coming in they're relatively slow moving. But if they were to happen overnight, if you were to go to sleep, you might not see a single instance of a hurricane outside. There might not be even a leaf blowing, or maybe a bit breezy, but this thing could hit in the middle of the night and you'd have no idea. So now at least they have these storm trackers, these satellites that are tracking these sort of things, where they can see the size, they can predict the paths. These are really important, and then issue these warnings to people to evacuate in time for before these things actually come in contact with any sort of people or civilization. So it's a bit terrifying to see that this is happening, and hopefully we won't have to deal with this sort of thing in Ireland.
Mm.
People are not out of the woods yet. And it's definitely still impacting the islands over there. So something just to keep an eye out for. Have you seen anything interesting in the news that's space related?
I'll be honest, I've just been doing a ton of research on asteroids ever since last week's discussion. And by research, I mean I've rewatched Armageddon twice.
Did you
Um,
actually?
yeah, well, I watched it as best I could. I had to watch it twice because I kept dozing off in the middle of it. It's not as good a movie as I remembered.
I don't
It's
remember it at all, to be honest. I was watching a few things about asteroids ever since we were talking about it. Of course, I keep getting fed asteroid news now. And then I was watching a video that was really well done. And they put a clip in. It actually might have been a NASA video. I can't remember who did it, but there was a clip from the movie, and I was like, geez, I don't even remember Ben Affleck's in that movie, isn't he?
Ben Affleck's in that movie, and so is Owen Wilson, actually, because I remember we were saying a few weeks back, we were deciding who would he send to space, and I'm like, Owen Wilson, we should send Owen Wilson to space. I take it back, it didn't go well for him. We're not sending Owen Wilson to space.
Yeah, so tell us a little bit about this. It's a simulation, isn't it?
It's like an activity where they like get together a whole bunch of experts from different fields, and from what I can gather, like they set a scenario and wanted to figure out how well we would be able to handle it, and they envisioned an asteroid that might strike the Earth with a 70% probability of striking Earth in 14 years, and decided, was there anything we could do about it? And at the moment, no. Now, I haven't had time to dig into it in great detail, but it seems like the challenges are more bureaucratic than technological, which is understandable. So any kind of a space mission involves lots of different agencies or companies and even different nations working together. And so, the scale that would be needed of intergovernment organization, at a time that's kind of fraught with like conflict and election cycles changing and all of this kind of stuff, it's just we're not well positioned for it. So I think that they're talking more about like we're not prepared as a species to tackle a united challenge like this in the same way that we kind of had to try figure out during COVID with mixed success as well. It was a global pandemic and we saw a lot of successes but also some failures. So it's for me the bureaucratic challenge is interesting. I'd really like to speak to like sociologists and people who understand like the psychology of like how people act in crowds and like what's going to be needed to bring that kind of cooperative spirit together, because that's a challenge I can't even begin to get my head around. Like there's just so many different stakeholders at play and there's so many different motivations for different people. And I mean, if you took the COVID analogy, let's say that NASA did discover that there's an asteroid coming for sure in 14 years, you got to imagine that we'd encounter a lot of the same problems that we did face with COVID-19, in that, some people would be like, it's fake news. We don't believe NASA. You can't trust them space agencies. They're just looking for reasons to divert funding. Or, like there'll be all these conspiracy theories that will throw out and people will be like, well, this isn't our problem. Somebody else is going to pay for it. And, it's just, I could see a lot of that stuff happening. And how you overcome that, I don't know. I do know that we can do it because we have done it in the past with chlorofluorocarbons and the ozone layer. So there has to be lessons that can be learned from like how we pull that off. I'm not sure what's changed, globally in how we interact with each other since then, but it's something I think we do need to overcome, because we don't want to like get wiped out by an asteroid size like the one that wiped out the dinosaurs. I don't think it's going to happen. It's not very likely, but a small enough percentage chance over a long enough percentage time means something bad could happen. And it's not just the devastating ones you got to worry about. You were talking about climate change, and I think a lot of people do think, oh shoot, that's going to look like really, really intense tropical storms, or it's going to look like freezing. But here in Ireland, one of the things we've seen is that the weather has become so unpredictable it's disrupting agriculture. Like earlier this year, we saw that the Farmers Association of Ireland were discussing how they'll have to switch to a different potato crop because our season is no longer reliable. I think the rooster is the main potato that we grow here, and it just isn't getting a long enough sunny season now to actually reach maturity and avoid blight and all this kind of stuff. And it's something we're seeing in other nations as well, that food security is getting impacted. So, it doesn't necessarily need to be a world-ending asteroid to cause a lot of problems. A big enough one hitting a big enough population center would still be really, really bad news. Or one hitting, just off the coast and triggering a tsunami would be really, really bad news. So we need to be able to deal with the not so, devastating world-ending scenarios just as well as we need to be able to, end up with potential planet killers as well.
It is interesting that we haven't had a huge impact over a highly populated area. And I guess we're lucky in that way. Because we have had mass extinction happen before. This is not like we're not completely immune to impact. And well, you're the dino expert. Do you know anything about that
Yeah,
extinction?
you were mentioning actually the Yucatan Peninsula and how the Cat 5 hurricane is heading in that direction. That is where the asteroid struck, was in the Yucatan Peninsula. It was big, like you can't get your head around how big this thing was, like 6 miles. So like it's so big that when it hit the planet, the part of it that hadn't hit the planet yet was still so high. If you were flying by in an airplane, you'd crash into it. Like it was still 6 miles up in the air, that deep. Oh, absolutely enormous. And it created a crater that's, I believe it was 150 kilometers of a diameter.
Well,
Like
isn't the Yucatan Peninsula the way that it's structured, how it's got that kind of half moon shape? Isn't that because of the impact crater?
yeah, it's a residual part of the impact crater. Basically, it created stress weaknesses in the limestone there. So there's lots of like little holes that have been generated in the limestone that fill in with water now, and they kind of perfectly map out for the portion of the crater that's still visible on land. Most of it's underwater now, but when that struck, it triggered all kinds of horrific effects, like in the immediate vicinity. But it also seems to have triggered tidal waves that they're not 100% sure if they came directly from there or if they triggered earthquakes that then generated additional tsunamis. Like I was looking at a study out of North Dakota where they found a whole bunch of like marine reptiles and dinosaurs and birds and fish and all these different things just piled up dead on top of each other in North Dakota at the same time that this had happened. So obviously the tsunami came out with all these marine reptiles and everything and drowned a whole bunch of like land dwelling animals, and they just all ended up on top of each other. And like the effects, it's just impossible to get your head around. Like the initial impact sucked. You wouldn't want to be anywhere near it. Like you've got the tsunamis, you've got like molten rock raining from the sky, you know, this pressure waves, intense heat. And if you survive it, like the dust cloud that was kicked up prevented the sun from properly penetrating the earth. Like it didn't completely blot it out, or we'd have had no, life left, but most of the large plants would have died off. You'd have been looking at things like ferns being the first things to kind of recover after this impact. But like the planet as a whole was impacted by this, which is something that's really hard to get your head around.
Yeah, I was seeing something that said, if I remember right, that experts are saying if we got hit, it wouldn't be the actual impact that would do the most damage. It's actually the winds, the really intense winds after, and then the heat, and then tsunamis. That would be the biggest issue, the most destructive, I guess, things that would actually wipe out cities, and especially coastal cities. You think like how many cities are right on the ocean. Actually, I just want to go back to, you said there were little holes in the limestone.
Yeah. So I think it was the underlying rock was created, like there were fissures and stuff created underneath so that the limestone over time collapsed in on top of it. I'm not 100% sure, but they're not, they were initially attributed to like holes created by the meteorite. But that's not correct. It was an underlying weakness allowed these holes to fall down through.
Do you know what cenotes are?
No.
I'm just wondering, I don't know how big the holes are. Like I know in Mexico, they're really famous for
Oh, wait.
cenotes.
Yeah, yes, actually, those are the
them?
little hole. That's them, yeah. So those, sorry, yeah, I didn't realize that's what
Ah.
they were called. Yeah.
Jeez.
So, yeah, those are an after effect of the asteroid, but not directly attributed to them. And again, it's a lot of the, as you say, the injuries and stuff that we would have to worry about are not directly attributed to the asteroid itself. If one were to strike land, only a relatively small amount of the energy would actually be channeled down into the Earth itself. Most of it will go laterally or right back up. So you'll see like rock heading up into space. You'll see pressure waves heading outwards from it. Very little actually goes into the Earth itself, triggering things like earthquakes and volcanoes. It happens, but like relative to the amount of energy that's available to it, very little of it actually goes into the Earth itself.
That's actually, well, this similar, but not quite exactly the same. I got really into watching, I don't know, I got into watching slow motion videos of this guy. They're just so relaxing. And what he's doing is
the slow mo guys
like,
on YouTube.
what?
Is this the slow mo guys on YouTube?
It's slow motion videos that are absolutely like, they're extreme kind of slow motion, and he's bursting balloons filled with water, or dropping things into either colored liquid, or dropping them into water, and then the water's going through. So like he'd have like something with holes in it that he would like drop onto a pan of water, and then watching the water. It's doing exactly what you're saying. That's what made me think of it. So most of the impact, or most of the energy, isn't actually going down. It's actually getting, the water's like shooting straight back up or out to the sides. But he does it in a really artistic way, that everything that he's doing, the water's like dancing and moving, and it's so nice to fall asleep to. This is what I do to try to fall asleep. So actually, Speaking of sleeping women that have been impacted by space, we do a lot with Anne Hodges, actually. And if you've never heard of Anne Hodges, she's the only recorded person to have been struck by a meteorite and survived. She actually survived. The poor woman, if you ever see any images of her, because this happened in 1954. So this is a time when photographs and things were taken, and she did a lot of interviews. So there's actually videos of her and things. But you can see the photographs of what happened because she was hit in the stomach. The thing came. I think she was asleep during the middle of the day. I don't. Do you remember if it was nighttime or anything? I feel like she was taking a nap.
I think she was taking a nap. Basically, the meteorite came through the roof and bounced off her radio, so it didn't like directly impact her. So she probably survived as a result of that little bit of slowing down from hitting the radio. But yeah, it gave her a pretty sizable bruise. It's and like we've got a cast of the meteorite at the observatory of BCO as part of the Anne Hodges exhibit, and that thing's not small. Like you're talking something the size of like a 1 kilo bag of sugar. Like it is sizable.
Yeah, and you
And
would think that was bigger before it actually came in contact with our atmosphere. So it would have burned up and broken up and everything, and then come through her roof, hit the radio, bounced off of it. And I mean, the amount of damage it did to this poor woman's body, even after being broken up and going through a roof, hitting a radio. I think it's interesting though that it is part of in the middle of the day, because I think a lot of times we think of space at night. We equate those two things, but it doesn't mean that these impacts are only happening at nighttime. Like it can happen in the middle of the day. What we're trying to avoid is exactly this kind of thing, is being able to detect huge chunks of rock in space that could become a threat to us. And we have space agencies that are doing this, but we are very far off from being able to detect something that size.
We're not ready yet for a scenario like that, like to tackle it meaningfully. Now, technologically, we've done some really cool stuff very recently with like the DART mission. We were able to deflect an asteroid with like a little moonlet going around it by striking it really hard. We sent a spacecraft. I think it was 22,000 kilometers a second. It was traveling, like would go around our planet in 2 seconds, and it was about the size of a vending machine. And we hit this thing so hard that we changed its trajectory. And that's what we're thinking we'll need to do, because like if you think of the movie I mentioned, Armageddon, like the goal was let's drill into it and blow it up with a nuclear bomb. If we're going to be dealing with this stuff, what we are going to want to do is deflect them, send them somewhere else, or just get them to hit the atmosphere at the right angle that they'll bounce off or disintegrate. And the DART mission effectively was a nice proof of concept of that, and we could potentially do that. Now, the scale needed to like have a whole bunch of DART missions ready to go, to tackle any particular threat that may emerge, that's trickier. And spotting asteroids that are potentially going to be a problem is really tricky. Like the last big one that didn't quite impact, it actually blew up in the atmosphere and still caused a lot of damage, was only a few years ago. It was the Chelyabinsk. I'm so sorry to any Russian viewers if I've butchered that.
It's one language I didn't study in school out of the 8 million that I did, so you're on your own with that pronunciation.
But that meteorite, it struck on a day when we were like putting a lot of effort into watching another one that we had actually seen, and we're like focusing telescopes on this thing that was going to arrive 16 hours later. It was going to be passing quite close by. There was no real risk of it striking the Earth or anything, but like we were, we saw it coming. We said we're going to keep an eye on it. And as we were looking at that, the other one came basically from the sun, so it's harder to see. And it blew up over Russia. It did a lot of damage. Something like 7,500 buildings were damaged, mostly like glass getting blown out, but also about 1,500 people were injured. Again, mostly from glass. It's not like somebody was struck by chunks of meteorite or anything, but there was temporary blindness in some people because of the sudden blinding flash. So they can be pretty significant even if they're not planet killers. Like this thing was quite small. In relative terms. Like the biggest detonation in recorded history was the Tunguska explosion. I think that was also in Russia in 1908. That blew up in the atmosphere and cleared something like 2,000 square kilometers of forest.
Do you know what's
So
interesting though is that they don't really know exactly. This is like the prevailing theory, but they don't actually know what happened. It is really because it was so long ago. Where this last one that you were talking about, it was recent, and so you have dash cams that recorded, and you had all of these different, even just regular surveillance, CCTV footage, and things that recorded this thing coming through the atmosphere. So you had a lot of different angles, and you had a lot of information as it was coming through. Even though we didn't detect it in time, we still had a lot of recording of it actually impacting Earth. Where this one was, what was it,
1908. So it was actually early part of the century. Yeah.
I didn't realize it was start of the century, but I knew that it was in a place where it didn't have, it landed in the middle of Siberia. So there wasn't a lot of recording happening at that
Yeah.
time. Well, there isn't any recording of it. There's no video or anything like that of this impact.
They don't think it actually made landfall. They think it exploded in the atmosphere. Or there was actually a recent enough study by a few Russian scientists. It hasn't been picked up to any major extent. So I think the original theory is still the prevailing one, but there's some evidence to suggest that it bounced off the atmosphere. So it may have actually come down, created this pressure wave, done a lot of damage, but then bounced off back out into the solar system again, which would, explain the absence of meteorites fragments on the planet. But that's the other side of that whole thing that I find quite interesting, and it has been a little bit reassuring as I've done my panicked research. I was always worried that if an asteroid hit like the middle of the ocean, it would just trigger like global tidal waves, and for a long time people seem to suggest that was something we needed to worry about. Relatively recent research seems to suggest that that's actually the best case scenario. If it hits, it's not as likely to trigger a tidal wave. A lot of the energy just gets absorbed by the water. You get other problems like vaporized water, and then you've got a ton of water vapor, which acts as a greenhouse gas. But tsunamis aren't as big a problem. You might have an initial one quite close, but you're not going to get like a planet covering one. So because we're 75% covered in water, that's, a major plus for us not getting absolutely wiped out by an asteroid. You don't want it hitting land if it's that size.
Well, that was just by chance that landed in the middle of Siberia, because had that landed in the middle of Paris or Moscow or London, it would. From what I heard about that impact, the light was seen from London all the way across Europe throughout Asia. So this was a huge, huge impact. And even though it was so big, there's very little known about it, because when they tried to go in and explore the area, it is a very remote location, so it's difficult to get to. But then on top of it, the native people there were so panicked about the explosion that happened, because they have a thunder god, and so they had thought that they had done something that displeased the thunder god, and that this was him being angry. So they would have been the actual eyewitnesses to, would have been the closest ones to this impact, and didn't want to talk about it, and wouldn't talk about what they had witnessed or seen. So it took a very long time, because it was actually a first expedition that basically they got nothing out of it. And then the second one wasn't for years. So there was a lot of information lost there. And so they don't even actually really know where it hit. There's a good indication, because they can tell by the trees. I think it was something like 80,000 trees were lost. And just they're just gone. And then, but what's really interesting about it is that the reason they think it blew up in the atmosphere is because they're right in the center where they think the epicenter of the impact would have been. The trees are standing straight up, but they look like electric poles. Like they're just stripped. They're just the trunks, and they're just upside.
Sure.
They're just straight up and down. So, and then everything is kind of like radial blast. You see these trees just flattened everywhere around there. So it's a really interesting, mysterious. So there's actually a ton of conspiracy theories. I got very little sleep last night because I did something very stupid, and I had coffee after dinner. Really bad idea. So my brain's just like, oh, you want information? We're not giving that to you today. But there are loads of conspiracy theories around this. And you can think about the time period too. Sorry, you're right. It turn of the century because now it's all clicking. So there was a lot of like, oh, was this like a bomb, a test that went off, or was this like there was a crazy theory about Nikola Tesla was trying to test some invention that he had about making wireless communication possible across the globe. And he had a friend that was doing a polar excursion and wanted him to try to test this. And then it went wrong and it blew up over Siberia. And then of course there's the whole aliens crash landed, and a lot of it is just because there's they weren't able to get that sort of information very quickly at the beginning. And it was in such a remote location. So there's a ton of fun little rabbit holes to go down with that one. But it is an interesting thing to know that these kind of impacts can happen. And there are a lot of things out in space that we can't see. Because when we're talking about, I think we mentioned this before when we are talking about looking up in the night sky, looking at planets, you can see with your eye because they're bright, they reflect a lot of sunlight. But these objects are quite dark. So these rocks out in space, it's like trying to find a chunk of charcoal against the blackness of space. So even with your best telescopes, it's going to be really hard to do. And so a lot of times when you're looking for them, you're kind of looking for anomalies against other parts of space. So you're like, oh, something's missing there. Oh, but now it's missing there. And it's like, oh, well, there's something dark moving in front of it. And so it's not impossible to track these, but it obviously, if something black moving as the blackness of space, the smaller it is, the less of a chance you're going to find these like little anomalies that happen. So one thing that's really useful is we have great telescopes, and we've got a lot of telescopes dedicated to NEOs, so these near Earth objects, and they're tracking and trying to categorize these near Earth objects and put them into categories of, are these ones that we have to be worried about? Let's calculate their courses. Let's see what their orbits are. Are they in danger of actually coming in contact with Earth? And watching them and monitoring them. That's great, but like down to a certain size. So this is where we have the use of amateur astronomers, because they can be out at all different times around the globe, and a lot of them feed into the data that's out there. So they do a lot with tracking asteroids, because they could be looking at other objects, for example, and then notice that something's different with their data and they're picking up something else, and then they're able to detect things. So there are a lot of people out there looking into the sky and looking to see what we're in danger of. So far, luckily, we haven't found anything that's huge and something we have to worry about. Every now and then we get a surprise because they're not all perfectly predictable, because we could have something. So we're looking at things inside of our own solar system. And so those could be a bit easier to track, but then it's more difficult when we find things coming from outside of our solar system that could just appear out of nowhere. So space is kind of a scary place, and we want to keep an eye on it. And the DART mission is a great example of essentially like science fiction coming to life, because it's this idea of, well, let's just go push the asteroid out of the way if it is going to be a problem. And so we tried it and it worked. So, and what's great about that is that you only have to, if you find it soon enough, this is the trick. This is why we want to be monitoring the skies and monitoring what's happening out there and what their orbits are, or what their paths are, either way. And if we find them soon enough, we only have to push them out of the way by a few centimeters. Doesn't have to be that far. And then they're moved enough that they won't be a threat to Earth. So this is why that mission is such a big deal, because it really is a testament to, like, we have a chance at actually protecting ourselves from becoming the dinosaurs.
That is a good point. Like, as much as I'm worried about this, it's only because I'm not worried about it happening in my lifetime. Like, I think, humanity we've got a finite time on this planet. Like, we know for a fact the sun will burn out one day. Like if we do want to persist as a species beyond the lifespan of the sun, we're going to have to figure something out. Maybe we have to become interstellar species. We won't ever get that chance if we get hit by an asteroid first. So right now we don't have backups for humanity to persist in this universe. So I think it would be really, really prudent on us, as far as we know, we're the only intelligent life in the universe because we haven't encountered anything else yet. It seems like we have a moral responsibility to hang on to that, and part of that is to keep an eye out for threats. And it's been 66 million years since the last really, really bad one. We used to think it was 65 million years. I learned recently that they were able to figure out that it was exactly 65 or 66, not 65. Because the iridium deposits, so iridium is actually really rare on Earth, but it's really, really common in meteorites. So there was a huge iridium deposit right after what they call the KT impact, the one that wiped out the dinosaurs, and they were able to really accurately age it. So it's actually 66 million years. So it's been 66 million years since something the size of the one that killed the dinosaurs has struck. We've had a lot of smaller ones. I think it's every 60 years or so on average. We get a decent sized one, kind of like the Tunguska or the other one hitting somewhere on the planet. It just hasn't hit anywhere populated yet. So it's not something anybody needs to be losing any sleep over. But that doesn't mean we don't need to be sensible and start looking at it as a real threat and something that we should, as a species, be putting an effort into protecting ourselves against. Like when we talk about how impactful these things are, we very often frame it in terms of nuclear blast. So Hiroshima was, I don't remember the exact number, but it was in kilotons. I think it was 18 kilotons. The Tunguska explosion has been put somewhere in between 3 and 50 megatons. So like you're talking many, many, many times bigger than the biggest explosion that most of us can get our head around. So what's kind of cool about that is that as part of our collective effort to, stop using nuclear weapons and to not repeat the horrors of World War II, we've, entered into these treaties that track and detect nuclear explosions around the planet, so that if anybody's doing any kind of a nuclear test or whatever, that we'll know about it. Those devices are actually giving us some insight into asteroid impacts. So we'll be able to detect if something large does trigger these devices. So we're starting to build up. Now, if it's hit the planet, it's already too late, but it's part of a sentinel system. Like the idea that we could, put other telescopes further out, even on maybe secondary planets, that are monitoring for threats is a cool idea. Like we should be expanding our network and looking at the sky. Astronomy is cool because we want to be looking at the sky to find stuff out in space. But if we also find threats while we're at it, you're killing two birds with one stone. So it makes all the sense in the world to invest in it as kind of a insurance policy.
Yeah, huge insurance policy for sure. And I just realized that I said, when you were talking about Tunguska, and I think I said it was 80,000 trees, and it was 80 million trees, and it was 1,000 times. It made me think about it when you said the bomb. It was 1,000 times stronger than the bomb, and it was 80 million trees that it actually decimated. So, yeah, that's not the kind of impact you want to have, especially over a highly populated area. And I don't know if you realize this. This is pure coincidence. We wanted to talk about asteroids because of the NASA experiment, but actually, we're just a few days after the anniversary of that event. Did you know that?
Didn't actually.
It's
Wow.
the 114th anniversary, I think, of the event happening. Oh my God, my math might be completely wrong. 116 something. Anyways, it is it's June 30th was when the impact happened.
Oh,
So
wow.
that's actually dedicated as asteroid awareness, that day in particular. So this is any sort of asteroid funding and research and stuff is recognized on that day. And it is a day to raise, we're just coincidentally right after, we're only a couple days after the anniversary here, raising awareness about
That seems pretty bad. Like we knew about the KT asteroid since like the 80s. It was a father and son team that figured it out. So that's 66 million years ago that a big asteroid hit us. It's been 114 years since Tunguska, and it was only in the last 2 or 3 years that we finally hit an asteroid back, and we're like, right, we got him. I just imagine like it took us that long to retaliate and be like, all right, stop messing with Earth.
Right? Yeah, I mean, I actually was watching, I think it was a congressional hearing about asteroid impacts, because then um, the government was kind of taking it seriously and saying, well, what do we do if? So essentially, what they were saying is that the risk of us being hit by something that would just, like the size of the dinosaurs, that'll wipe out civilization, quite low. This is very, very low. But the problem is that even if it is just that one, if we get hit by one, that's it. So regardless, we still have to have a plan. I mean, in a lighter note, can we switch to a bit of a lighter note? Maybe not
Oh,
so.
absolutely.
Don't want to end the podcast making people think that like the world is ending and they're going to go away and have sleepless nights. You're having sleepless nights. I'm drinking too much coffee. No one's sleeping. Let's make sure people can go out and enjoy Astro and feel good about the night sky again. So when we have smaller pieces, we don't have asteroids or meteors coming in contact with us and trying to eradicate the human race or everything on the planet. We do have meteor showers, and we have a few good ones coming up.
So just in time for July 4th, Independence Day, right? Tomorrow?
That's oh my gosh, yeah, it's tomorrow. I'm the worst American ever. So there is the middle of August is a great time. So this is a great time to start thinking about it if you want to try to see the Perseids. They're kind of regarded as the best meteor shower of the year. They go on for a very long time because it's about a week, but there's about 2 days where you really get a good view of a meteor shower. And August 12th is around then is usually when it peaks. And this is essentially what happens is when we are seeing all of these meteor showers happen and you're seeing all these streaks going through the sky. So if you don't know what a meteor shower is, they're basically just a bunch of shooting stars in the sky. If you've ever seen a shooting star going across the sky, yeah, you have that happening more frequently. So you might have a couple of minutes or uh, yeah, I think a lot of times people think it's like just nonstop, but you look up in the sky and there's just loads of streaks all over the place. But you might get maybe 10 a minute kind of a thing. But basically what you want to do is if you want to get to a dark sky, just like everything else in astronomy. So the darker the sky, the more you'll be able to see. And what happens, what you're actually seeing is the Earth moving through a debris trail. So, for example, with this particular meteor shower, it's moving through the tail of a comet. So it's Swift-Tuttle. And it's a very predictable one because we know that orbit and we know when we come in contact with that tail, and it is the same time every year. So you can start seeing them kind of at the start of August. You might get a few shooting stars in the sky, but then as we move towards August 12th, and you really start to see them coming through. And I got very lucky one year, and we had decent weather here in Cork, and geez, actually, that was about 6 years ago or so now, maybe more. And I tried to get out of the city by bus. So I actually went up to Blarney. So there's a campground outside of Blarney Castle and outside of the town there. And I just went out camping because I was like, well, it's not that far from the city and I'll be able to just get away from the city lights a bit. And I got my first pictures of a shooting star. So
Cool.
it was actually really cool because I was doing I was just trying to capture some stars. I was just trying to do a bit of landscape, but there were just so many that I was actually able to get a few and made it look actually like a time lapse, and I could actually see them coming through the pictures.
That's awesome.
And that's not even that far out of the from the city. So I wasn't even like a super dark sky spot. I wasn't out like in Kerry or West Cork or anything like that. And so if you are out and you are looking, that's a great time to start. If you want to try to spot your first shooting star. Have you ever seen the
I don't know if I've seen the Perseids because my only recollection of seeing like a ton of meteors in one night was maybe, oh god, maybe 20 years ago now. How old am I? Yeah. Oh, that's sad. A friend of mine came to hang out with my parents. My parents were away on holidays, and I was like looking after the house. So obviously we were doing the typical teenager thing and having a wild party of two dudes, not doing anything fun except sitting out in the garden looking up at the stairs. Yeah, we were such nerds. But yeah, we just noticed a ton of meteors. It was really cool. They were all white, but we do get a lot of queries in via like the social media channels, and even to the email saying, "Hey, I saw a green meteor. What's up with that? I saw a red one. What's up with that?" And like, I know you were doing some research on which elements triggered which colors, but it's effectively the same as what happens in fireworks, right?
Yeah, and I always mix them up because I don't, to me, for some reason, they don't seem I don't know, in my mind they just don't make sense. I feel like they shouldn't be the colors that they are, so I mix them up all the time. But it's like if orangey yellow is sodium, yellow is iron, which in my head I don't know why that should be green. So that's why I'm always like, I think I said that to you the other day. I'm like, yeah, I think iron's green. Definitely not. It's yellow. Blue green is magnesium. Red is nitrogen and oxygen. I think I got that one right though, because I always think is oxygen, but I always forget about the nitrogen. Violet is calcium. So yeah, when you're seeing them come through the atmosphere, if you're able to detect a color, then what you're seeing is that basically the makeup of whatever the material is in the meteorite coming through, or the meteor coming through.
Actually, yeah, I'm gonna commit the cardinal sin of podcasting and throw something visual up. But for people who can't see at home, I've been fiddling with this the whole time. That's what they look like. So if you can't see it, it doesn't look as rocky as we often describe it as. It looks more like a lump of iron, or
If you've ever
Or
seen
a
like the
lump
head of
of
a
coal that naughty boys that have parties while their parents are out of town get from Santa Claus. It's about the same size as that.
yeah. But I love showing them to people because they're always blown away by how smooth it feels. And that's because it's been like burnt up in the atmosphere and like basically sanded down and kept smooth. But this one had iron in it, so this one would have glowed. What color did you say, Danielle?
Iron is yellow.
Yellow. So this would have glowed yellow before it came in. And it's now ferromagnetic, so it'll actually move a compass for you.
It's because obviously I have a couple on my desk as well. It's the weight of them. So that's maybe the size of a golf ball, maybe about that.
That's a lot heavier than a golf ball.
But a lot. So you think of like even a rock that size, that's way heavier. So I can't imagine actually being like poor Ann Hodges. Could you imagine being woken up by that coming through your freaking ceiling? It's really hard to explain because it doesn't. As soon as you hold the thing in your hand, you just don't expect it to be the weight that it is. It really is so super heavy. So this is why something that small could do a ton of damage, even that what you have in your hand there. We don't want something the size of a skyscraper crashing into us.
It is funny actually how like looking into the night sky can trigger like, oh my god, I'm seeing something supernatural or terrifying. And we've mentioned in previous episodes that like when stuff is up there and there's no frame of reference for how big it is, like the moon can look bigger depending on where it is on the horizon relative to like up in the sky. I've been frightened quite a few times by Chinese lanterns because they look like enormous fireballs. When they catch fire and like suddenly drop, all you see is this just flame dropping suddenly out of the sky, and I'm like, oh god, here we go, this is Armageddon.
It is just interesting that any sort of anomaly in the sky, especially at night like that, seems to be equated to like the end of times, when the stars are falling from the sky. But actually, well, it was for the dinosaurs. So do you know what? There's a bit of truth there.
Ancient cultures were more prepared for this than we were. They seem to recognize the threat a bit better than everybody in that Leonardo DiCaprio movie.
So that's all. That hopefully was a little bit more up. What am I trying to say? This is why I'm not doing coffee before dinner anymore, coffee after dinner anymore. Uplifting. Hopefully that was a little more uplifting.
We're ending on a more hopeful note than we started, yeah. I think so. That said, I want to know if everybody at home is as worried about this as I am. What do you think? Should we be funding, asteroid detection and defense agencies? Actually, NASA have a planetary defense office, which is just the coolest office name ever. Like, I want to work for the planetary defense office. I don't care in what role. I just want to be like, hey, I'm Rob, planetary defense officer. Sounds cool.
I would love to know if anyone has ever seen a shooting star. Because I'm very surprised at how many people haven't. Was talking to people recently, and I don't know if it's that people haven't or they don't know if they do see it, they don't know what they're looking at. But I was with a crowd of people recently, and I think I was the only one who's ever seen them before. And maybe it is living in the city, because when you're in the city lights, it's harder to actually to see because you listen, you don't have to go out on certain nights where there are meteor showers. You can actually just go out and just look up, and this is the thing. I live in a bit of a dark area at home, so I could just be on my back deck at night and just look up, and I know I'm going to see them. Or even where my cabin is, it's quite dark, so at any given night I can go out and I can see these. So for me, I just thought that was just the norm. Like, yeah, okay, when you see a shooting star, and they're like, when you see a shooting star, who sees shooting stars? I'm like, wait a minute. What do you mean? So let me know if you've never seen one, and if you would like to know some tips and tricks on where to go and how to get your best chances to see a shooting star. Let us know in the comment section below. If you are terrified of asteroids, also weigh in. What do you think? Oh, this was the thing I was going to say. So there were 3 options. You could deflect the asteroid. You could blow it up into pieces with a bomb, or like, what would your other option be? What would you do? What do you think? I think deflecting would be my option, because I think blowing things up into a million pieces seems like a really scary thing, because then you have a million pieces. It's almost like the best advice for sound terrible. Best advice to murder somebody is you don't chop them into pieces, because then you have more pieces to find to give away, and it'll give you away. Where if you just have one body, then you have one problem. So same thing with an asteroid. You've got one body, you got one problem. You blow it up, you got multiple problems. That's the way I'm looking at it anyway.
Tune in next week for more handy tips on how to get away with murder from Danielle Wilcox.
So if you've got good ideas for how we can protect the Earth and humanity,
I thought you were going to say if you've got good ideas on how to hide a body, and I'm like, oh God, no. We do not want to. Well, you could fire a body at an asteroid, and I guess we're not going to find it, but yeah.
All right. Well, I clearly need some sleep. I might go now. But thanks everyone for tuning in for this week's episode. And of course, if you have any comments, drop them in the comment section down below, or get in contact with us on any form of social media. We're basically across everything. If you Google Black Rock Castle Observatory, or go into your social media and put Black Rock Castle Observatory in there, you will find us, and you can comment and it'll get back to us. So we hope you enjoyed this episode, and hopefully we will see you, or hopefully you'll be listening to us again next week. We'll talk soon. Bye, Rob.
Bye, folks.